I'm Hari. I'm going to be talking about acrylate chemistry-based polymers. So, acrylate monomers pretty much form a lot of polymers. You can make lots of composites. You can add ceramics, dilutants, and a lot of fillers in order to tweak their mechanical properties and other properties in for you to get pretty much a lot of things. One of the main reasons acrylates are highly reactive, and also they have a vinyl group in it. There is this carbon-carbon double bond, which sometimes acts as a photoinitiator as well. So it helps in forming photopolymers, basically. So some of the properties of the material is it's photo and UV curable, and then it has good green strength. Green strength, as in as a powder or as once before you sinter it, it can withstand some mechanical strength. I mean, it can maintain if you're gonna do some mechanical operations on it, it can still withstand. It can still have the mechanical strength to withstand those operations, and then it has fairly good temperature resistance and thermal stability, and it's biocompatible and biodegradable. So on the right, I've given a table of monofunctional and multifunctional monomers of acrylate monomers, basically. So what I mean by mono and multifunctional is it can be used as a diluent or it can be used as a monomer as well. So if it's a monofunctional, it can be used either as a monomer or it can be used as a diluent. In multifunctional, it can be used as both. So it acts as a monomer at the same time it acts as a diluent as well. So some of the typical applications for acrylate-based photopolymers are um, micro, micro biocompatible and biodegradable micro beds, micro needles, and micro wells for drug delivery and biomedical devices and stuff. Also, they're used in their tensile strength. I mean, their elastic modulus can be extended from zero point 0.4 megapascal to 8,000 megapascal. So and since you can get pretty much good intricate geometry from SLA, it's used in a lot of spray nozzles and a lot of automobile applications as well. So these are some of the numbers. This is from one of the papers which I'm going to be talking about later on. As far as handbook properties come along, I didn't exactly know exactly what to put in there because it's a monomer, and the property is going to depend upon what kind of polymerization you do to make what kind of polymer you're going to make. So, but I've still mentioned a few polymers, few acrylate-based polymers and their suppliers, and I've mentioned their properties in the next slide, though. So one of the most commonly used photopolymers is Perfactory SI 500 and Acryl R5. It's from Envision Tech. So they have fairly good mechanical properties. They have around 2,700 megapascals, and they have considerably okay hardness. And the right side shows the composition of what kind of monomers. What's the composition of the Perfactory SI 500? So it's basically made of methacrylated monomer and then an hexadiol acrylate, and then it's pretty much mostly acrylate and a little bit of titanium dioxide in it. One of the case studies is for Hypro EU. So they had to make a crop spray nozzle. So this was one of their latest additions to their products last year. The main reason why they wanted to use acrylate polymers is really highly reactive, and it polymerizes really fast. And they had to. The thing is, their housing assembly had a lot of interference in it, so they had to make like a lot of designs in a very short period. Like they made like around 5 designs by one whole day, like in one whole working day, in order to get it. And even though it's possible with other things, it was much easier with this because they were able to, since they were able to do some like colored filled polymers. At the same time, they did some transparent things as well in order to see exactly where they had that assembly problem and stuff like that. And they were with SLA, they were able to achieve some high tight tolerance specifications which they needed for the nozzle, and some features, some architecture inside, micro architectures inside. This paper is from the Journal of Micromechanical and Microengineering. So this one talks about different acrylate-based polymers, as well as organic ceramics with organically modified ceramics, which are pretty much which are also photopolymers with acrylate based chemistry in them. Um, The thing is, acrylates can be mixed with metal alkoxides as well as ceramics in order to get good mechanical strength. So their main thing was to see what are the different types of photopolymers, acrylate-based photopolymers, and armoses, that is what is organically modified ceramics, which that can be used in micromechanical systems, and they wanted to see at till what range they could spread the mechanical properties, but to specifically just elastic modulus. So what they did is they had a micro SLA device, and the properties of the photopolymers were tweaked by adding either mono or multifunctional acrylate monomers as well as cross-linkers for organic acrylate-based photopolymers. So the one of the advantages is that the viscosity of mono and multifunctional and monofunctional acrylates help in determining the viscosity of the overall photopolymer. So that makes it easier for them to manage, like have a uniform layer when they're curing their material. They also use some ceramic powders and fillers in order to increase the Young's modulus of the polymers and to reduce shrinkage too. So this was their these were their findings. So they saw that they were able to get pretty much good elastic modulus. So they had from zero point 0.4 megapascals to like 8,000 megapascals. So the zero point 0.4 is because they added polyethylene glycol, which kind of softens the materials too much. They say their main finding was that their main research study was to find out the mechanical properties of the photopolymers and to make sure that they can be used in micro engineered devices. So, and they found out that by changing the network density of the photopolymer as well as by changing the type of polymerization will take place, like is it like free radical polymerization or cationic polymerization, they were able to get tailored mechanical properties for their products, and also by adding solvents to aid in, like for example in osmosis where the ceramics are got as sol gels. So sol gels are, I mean, so they're not composites, they're not nanomaterials as well. So they are linked together. The inorganic compounds are linked together in a molecular level. So that way you get better properties than composites. So next one is the study of shrinkage strains in the acrylic photopolymers. So I chose this paper because this does not just talk about the shrinkage due to the process, but it's because of the chemical and thermal properties of the material which actually plays a role in the shrinkage. So they see that during their curing, either as UV curing or thermal curing, their experiences some residual stresses which are not relieved, and the material as such shrinks and because of that you have cracks and delamination in your things. They had a thin resin layer of around 0.156 millimeter, and then it was post cured. So they had two different layers. So they kind of use sandpaper to kind of rub the paper and then add an adhesive to stick both together, and they UV cure it the same as they thermal cure it as well. And then they're using it to find out. They're using projection method to find out with fringes in order to find out what kind of distortions and shrinkage which happens in the material. You can see from the left figure that, like after fabrication you have some kind of distortion in it, and the first image, the middle one, is when when it's thermal processed. Like after you make the for post processing you use thermal curing rather than UV curing, and then the right one is UV curing. So it is seen that UV curing is both thermal. UV curing is more in par with the elastic lamination theory, and it's more related to the chemical. The chemical shrinkage is more during thermal curing rather than just UV curing, because during thermal curing there is the the layers are over cured, which causes the distortion more. So these are my references.